All right. So what we're gonna do is we're gonna talk about this theorem. This theorem is very hard. So it's not very hard. So algebra 2, I already discussed about this theorem. If you have very good algebra teacher, and if you have Shapiro, I think he just assumed that you guys knew it already. I'm not sure if he can go over this one. It's a very simple theorem. It's like people take it for granted. It's me in algebra 2. I will actually teach you because I think that's a very important theorem for calculus. The chance of intermediate value theorem to show up, it's almost 100%. It's whether it's going to show up how many times. It's not whether it show up. It will show up how many times in the AP exam. And if it show up, it will be one of the easiest question or one of the hardest question for students. So hopefully that's easy. Okay. So I want you to look at through this. I want you to read that statement of intermediate value theorem. I know reading math textbook is completely different beast. Kyle, I need you to put computer away for now. Okay, so if you read this theorem, it's going to read like a gibberish to you because it says if f is continuous on closed interval, bracket a to bracket b, which is closed interval, that means including a and b, f of a does not equal to f of b, and k is any number between f of a and f of b, then there is at least one number c in a and b bracket such that fc is equal to k. How many of you guys actually can understand the statements? If you can, there's a future in you in math. If you cannot, I'm going to break down to you. So reading the statement like this, you have to read in the small pieces. Don't read the whole pieces. Okay, so what I mean is like this. Don't read the whole thing at once. So this is how I read it. In order for IVT to work, there was a requirement. I'm going to list down this requirement. The first requirement, f is continuous. So write down intermediate value theorem, requirement, and result. Okay, so this is the result. Result is at the second statement. So the first statement you want to break down says f is continuous between a and b, close bracket. That means including a and b. The second statement says fa does not equal to fb. That's kind of important because if fa equal to f of b, sometimes there is slight chance where no, that's not slight chance. There's a lot because you cannot see what a k is if f of a equal to fb. That third statement will not be true. The fourth statement says C is between A and B. That's pretty much like standard. The result is this. F of C equal to K, at least one C. More than one C. So far, you probably still don't understand what is going on. But I'll give you an analogy after I show you the graph. So I have a graph here. And this graph, it looks like this. First of all, we're going to start with the last statement. C is somewhere here. It could be here, could be here, could be multiple C's, could be a lot of C's. C is between A and B. So C is right here. This is C. K is going to be between those two values. K has to be between those two values. That's why FA does not equal to FB. Because if FA equal to FB, there is no K. Okay? So let's just say we have a 1 point here. This is the point that we start with. There's one at -3 here, and there's an output at here -2, or +2. Sorry, I can't read. So it's gonna says those are the things that f of a does not equal to fb. So my condition 2 is already fulfilled. My condition 1 is f is continuous. Now, how do I know a function is continuous? Can you name me a function that's continuous? Yes. Y equal to x. Good. A straight line has to be continuous, right? Yes.
You said a straight line or just
a straight line?
So would why like 1 to the x, would that be continuous? Is that not?
Right. 1 to the x. 1 to the x.
It's exponential. Or maybe just 2 to the x. Sorry.
1 to the x is actually a horizontal line.
No, I'm sorry. That was bad. 2 to the x, for example.
2 to the x. Yeah. 2 to the x will be an example of its continuous function. Yes. So it's hard to memorize all the continuous functions because pretty much majority of functions are continuous. Now, can you name me a function that's not continuous? Yes. 1 over x. If you have x on denominator, then that's where the function might not be continuous. Now, here's a tough one. Can you name me a function x is on the bottom, but it's continuous? It's an open-ended question, so it was x on the bottom, but it's continuous.
1 over 2 plus x.
No, x equal to -2 is not defined. There's an infinite amount of answer, by the way, but it's very hard to think of one. So anyway, if you have x on denominator, very highly chance that that's not a continuous function.
Can it be on the numerator as well? Or just
It can be on numerator, yeah, but it's denominator. So yeah, it's kind of hard to think about it.
Maybe I'm misunderstanding, but could you be like y equals 2x over x? You just cancel x.
2x over x. Okay, I see what your point is.
Or maybe
So nothing can cancel. How about that? Nothing can cancel.
yeah. Then that's fine. Yeah.
It's not as bad as you think. Okay. Yes.
The x be like the exponent?
Yeah.
Could you do like x minus 3x over, or x minus 3x over, or sorry, x minus 3 over x minus 4?
That's still not continuous at 4.
1 over x to the -2?
That you play the rule a little bit different. The x is still on the numerator on that case.
I'm kind of cheating, yeah.
Yeah.
I got you.
Yes.
1 over 2 to the x?
1 over 2 to the x.
Oh.
Okay.
1 over root.
1 over 2 to the x could be good. Yeah, because that's a continuous function. I was thinking about 1 over x squared plus 1. Because it doesn't matter what I do with the x, it's always positive. But 1 over 2 to the x is good. That's then that's why I said there's an infinite amount of answer. So so just knowing when it's not continuous. So 1 over x is not continuous. 1 over x minus 1 is not continuous. 1 over x minus 1 squared is not continuous. But there's some weird one that you can create. So it's really, like I told you before, it's really hard to create always statement because it's really easy to create a counter argument.
Yeah.
So it's harder to create an always statement. So that's the one thing that you have to understand. Now, so just say this one has to go through, guess what? If it's a continuous function, it has to go through 0. It has to go through -1 too. It has to go through 1. Why? Because all the value has to get through the value. So for example, I got a water bottle this morning, and if the water bottle is all the way full here and the label is right here, the label represents your K. All right? If you take a picture in first period and you take a picture at a 5th period, and it's right down here, that means the water has to flow all the way through the label, pass through the label. That's what intermediate value is saying. It has at least once. At least once. Can that be multiple times? Yes. You can drink it, filled it, drink it, filled it, drink it, filled it. You can pass more than once. But at least once, if you take a picture here, you take a picture here. At least there's no possible way you can froze the middle part and just drink the top and drink the bottom. At least not where the bottle is sitting right now. Right? Because water is a continuous function. You think about it, water is continuous. It's not, there's no asymptote, there's no gap. There's a gap, that means you can froze the middle part and just drink the top and drink the bottom, says Mr. E, you're wrong. But that's not possible either, right? I don't know, maybe it's possible. So thank you for the water bottle. Does that make sense with water bottle situation? It has to go through that label. The water has to go through the label. It doesn't tell you when though. That's why intermediate value is different. It doesn't tell you when did it happen. It just tells you there is a chance to happen. So that's what makes this question hard. The question's hard is because there is no defined value. You just had to prove it. I'm going to show you a question in a second. And this is actually the question I found on CLIP exam, which is college entrance exam. So at least going through once. Can I go through multiple times? Yeah. Can I go through 3 times? Yeah. You can go through 0 3 times. How do I show up as a question? This is how they show up in the question. They're gonna say, hey, f of x is equal to x cubed minus 1 between -2 and 1. And they say, tell me there's a f of c is equal to 1. Sorry, not 1, but I'm going to change this to 2. How do I prove this? So prove that there's a c value where f of c is equal to 1. Then you're going to say, okay, first requirement. The first requirement says, is this continuous function between -2 and 2? Yes, because all polynomials are continuous. B, they say is f, the endpoint, are they equal to each other? I don't know until I plug in, and I need to plug in. So that's going to be -9, right? Did I do my math right? If I plug in -2 into the function?
Yeah.
Okay. Now plug in 2, it's going to be what? 7. So is there f of c equal to 1? No? It went from -9 all the way to 7. We never go to 1? You have to go to 1, right? So there's a IVT proof that there is at least 1c. So 1c, where f of c is equal to 1. Can it be 2? Can it be 0? Can it be 10? No, cannot be 10. But it can be anything value between -9 to 7. This value can be anything -1 to -9 to 7. That's what I meant. Very easy. Yes.
What's that word before the
Proof.
Yeah, what's the word after?
That there is
IVT prove there. No, the word before there is.
that
Okay.
there is at least 1c that f of c is equal to 1. Okay, so that's that. So that's how intermediate value theorem will show up on your test. All we got to do is plug into endpoint and say this is a continuous function. Long as that endpoint is where the has the cover the k value, then you say yes. Otherwise you say no. Okay. So that's how the question is. I'm going to show you a club exam question. This is a club exam question from a college entrance exam. And I'm a textbook junkie. I'm an exam junkie, so I collect all the exams. This is a college algebra, so I show you this is a college algebra test. So the question is going to say this. The table above shows some value of 5th degree polynomial. Keyword, polynomial. Polynomial means what? Continuous function. Based on the value below, what's the minimum number of real roots of equation p of x equal to 0? So that's what the question is going to show. There's no calculation. There's no calculation, but it's going to show like this. If you understand the concept, you can be a 3rd grader, you can solve this problem. Sheldon's already got it. Ron Grudge already got it. Brendan got it? Okay. What'd you get, Brendan? Yep, there's nothing to solve for. That's the thing. It can't really solve nothing here. Danny's got it. Good. Gaio, did you get it? Huh? Okay, what'd you get? Nope, it's not 1. Is it what?
5.
Nope, it's not 5.
3.
Sheldon, what'd you get? 3. So 3 is right. How do you get 3?
Because negative 30 to 22, that's 1. And then back to negative 130, that's 2. And then back to positive 222, that's 3.
So there's.
It has to equal 0. At least, like, it has to go through 0 when you're going from a negative to positive.
Does everybody understand what he say? Gaio, do you understand? Yeah, Gaio, do you understand? You understand there's 3? Can you tell me? What?
So you're going from negative 30. You see how there's x 0 and then p of x 30 on the bottom? So when x is 0, it's negative 30. But when x is 1, it's positive 22. When you're going from any negative to a positive, like you have to go through 0. It's not like you can skip over 0, right? And then when you go, if you see like when x is 5, it's back to a negative. So until like 1 to 4, it's positive, but then 5, it's negative. So when you're going from another positive to a negative, it's like the same thing from going to a negative to a positive. You have to go through 0, right? So that's 2 times. Then right after to x equals 6, you're going back to positive 222. And then going to another positive. You're going from negative to a positive. So that's 3 switches in which you have to go through 0.
So it doesn't need calculation. That's what makes this problem hard. It just, you have to picture the graph of when it happens. And can I say 1? Yeah. Can I say px equal to 1? It's going to be the exact same answer. Right? There's no difference because that's not going to factor a lot because that's still within the boundaries. So those are the questions. That's how they're going to show up and things like that. So with the understand intermediate value theorem, I'm going to talk about the next one. The next one is not intermediate value theorem, is let me erase this. Sorry. Okay. So next one is not intermediate value theorem, is this one. The requirement for function to be continuous. There are 3 requirements. So first requirement is this. And this I just ask you this. I'm not even ask you to prove anything. I'm just going to ask you flat out. What is 3 requirements? I'm just going to be on the test. One of the things for sure on the test. It's not going to be on AP exam. It's not going to be this easy. But I'm just going to ask you, do you know the 3 requirements for function to be continuous? The first requirement. Sometimes I call it definition of continuous, but that doesn't really make sense. But I don't know what's the best way to call it, but it's just the requirement for them to be continuous. 100% of the time that this will show up. Also, it's a matter of how many times it show up. It's not a matter of, if it show up, it will show up. So I'm going to show you the graphing part of it. So we say f of a must be defined. I'm going to say a is defined, but it's a solid dot. That's it. That's the first requirement done. Does this function look continuous to you?
What does one say?
Define. F of a must be defined. If it's defined, that means it's a solid circle. But this doesn't look like a continuous function. It doesn't, matter of fact, it didn't even look like a whole function. It only has a coordinates, right? But nonetheless, it still can be a function, but it's not continuous because it's a 1 point. Second one, limit x approach to a of f of x must exist. Now, this one I'm going to color code this for red. If it exists, can you create a counter argument? Math love counter argument. Can I just say, hey, it exists? but it doesn't mean it's continuous. Mr. Ye, you are wrong. Yes, that's for sure true, because when limit x approach to a, the y value is 1, so limit does exist is equal to 1. And from the left side and right side, they are equal to 1, but this is not a continuous function. So I say, wait, I haven't written down the third statement yet. The most important statement is the black. They say f of a is equal to limit x approach to a of f of x. So what does that mean? That means this graph gonna move to like this. Then you say, now how about that, right? How about that? This is a continuous function. On the test, I'll just ask you what it takes to be continuous, or what's the requirement to be continuous. If you write down those three statements, you get 5 points. You're not going to get 0 on the test. Doesn't mean you will pass the test, but you will not get a 0. But at least memorize those three statements, right? Yes.
Can you explain like step 2, like exist?
Exist means if I reach from the left, if I reach to the right, even it's open circle, long as I reach one value, it still exists.
So as long as both sides come to one value.
Yep, we're going to talk about that next, because this is the next part. The next part is this. You done it with Chaparro's class? You did this before. Analyzing graphing algebraically or graphically. Yes.
Why'd you move the graph that showed that like?
Because they have to equal to each other. If they don't equal to each other, it's not a continuous function. So I move the graph up to make them equal to, because limit reached that point, right? And that point has to be a solid dot. So if solid dot's right here, I had to move up there to make it continuous. Does that make sense?
Yes. So if we had a question like that, we wouldn't like move it up.
Oh, you can move up, because I'll just show you the requirement for me to take. Because you're gonna tell me this counter argument is I can have limit exist, but doesn't mean it's continuous. Then I'm gonna say no. There's one additional thing. That graph has to be matched.
So you like have to translate it in some way for it to match.
No, you don't have to translate. They will give it to you. We're gonna give you a perfect example in this case. So what happened when limit x approach 9 in here? On the first one here, it says x approach to 9. What happened when it approached to 9? Danny? Just 2, yeah. It just reached this reach from both ends though. I'm gonna show you how to do it properly. If I say a 9 a single value, you have to approach both ends. And had to be really close, not be very far away. Reach 9 from a really close value from both sides. From both sides. The keyword is both sides. That's 2. What is f of 9? That's just the output. That's equal to 2 as well. Do you understand? Okay. Next one, C. What happened? Limit x approaching -7. I know you know. How about Sam? Do you know if limit x approaching -7? Is it 1? Okay. How about Tomo? How to say your name? Tomo? Your name, yeah. Toman? Noman. Okay. Noman, sorry. Limit x approaching -7 of f of x is equal to what? You says 1. Mason.
Could it be 3?
Could it be 3? Danny.
It'd be does not exist, right?
You'll be equal to does not exist. Can you explain to this group says does not exist?
It's because it's called a general limit, and there's just 2 things. There's 2 things it could be.
So if you approach this side, it's 1. If you approach this one's 3. So 1 does not equal to 3.
Yeah.
So limit does not exist. Does that make sense? Okay, so that means does not exist. Good. Next one. What happened to f of -7? Tony, f of -7 is what? Nope. Nicholas. f of negative 7 is what? It's gonna be the easiest part of the test. You have to get it right.
It just does not exist.
Kyle? F of negative 7. One is good. It's just look at a solid dot. Because f of negative 7 means when x equal to negative 7, what is my output? It doesn't ask you limits. It just asks you the evaluations. Yeah, there's a y-axis. You can see there's a y. Oh, okay, you have to see the graph. So you can take a picture of this. It's okay. When limit x approaches negative 7 from the left, Ilya?
1.
Is negative 7 from the left is 1. Good. How about negative 7 from the right? How about negative 7 from the right? 3 is good. Why 3? Because you approach this way to 3. And 1 is approached here is 1. But you're going to say, you're not going to reach from here, right? You're going to be, say, Mr. E, I can never reach negative 7. No, it's negative 7 from the right. So it's going to be from here, close to the right, reach this way. Otherwise, you'll never get there because you got to asymptote. It's like, Mr. Yeah, I got to asymptote. It doesn't make sense. No, it's negative 7 from the positive side, which is this part going here. Okay, how about negative 3 from the positive side? Brandon? Negative 3 from the positive side. 2 is perfect. Good job. Negative 3. Limit as x approaching negative 3. Sam? Samantha? Sorry. Does not exist. Perfect. What about f of negative 3, Mason? It's actually 5 here because you're looking at the output. You look at a solid dot.
Oh, I didn't see the solid dot.
Yeah, so 1, 2, 3, 4, 5. Oh, so 1, 2, 3, 4, 5. So f of limit x approach 2 is what? This one can be very tricky. This one's a negative infinity. Or some people say it does not exist and I cannot mark it wrong, unfortunately. That's kind of iffy. Depends on which textbook you go to, but they both answers not going to be repeated. But the last one is 1. When I approach infinity, it's going to plateau into the asymptote, so it's going to be 1, and that's all it is. Bye. Stop hosting debate meeting, taking kids away from my tutoring. I'm just kidding.
You debate?
I'm just kidding.
No, which debate? I'm curious. I know, but like which kids?
Well, I'm not snitch.
Yeah.
Snitch gets stitched.
I know. Snitches get mad stitch.
Yeah, I cannot do that.
Why do you like? It just doesn't like. I know how to do it, but for when you